And of course, there are other organs in the body that are communicating with the brain also. Your diaphragm, for instance, is communicating with your brain through indirect pathways about how you're breathing during exercise. And of course, your brain is controlling your diaphragm too via a number of stations, including the pathway that includes the phrenic nerve, which controls the diaphragm. The point here is that once you start exercising, of course, it has an impact on the organs in your body. They change the way that they're functioning. Your heart, your liver, your adrenals, your skeleton, literally your bones, and of course your muscles. And they are releasing things that impact brain function either directly or indirectly. Once you start thinking about exercise in that context, even if we don't parse each and every one of those pathways individually, you can start thinking about exercise as a multifactorial way of enhancing and changing brain activity so that it positions it to learn better in the subsequent hours and days, as well as modifying areas of the brain like the hippocampus by making certain brain areas literally bigger, more powerful at engaging the sorts of things that they do. In the case of the hippocampus, learning. In the case of the prefrontal cortex, context-dependent decision-making, updating strategies, these sorts of things. And generally speaking, exercise causes the release of things like BDNF, brain-derived neurotrophic factor, and nerve growth factor that enhance the health and stability of existing neuron connections. And something that is very rarely, if ever, discussed publicly, not because it's some sort of secret that people want to keep, but I just don't hear it discussed, is that BDNF is an activity-dependent molecule. It's a molecule that can serve to stabilize and enhance the growth of neurons, keep their connections in place, grow new connections, and it does so when neurons are active. So the point is that BDNF has to be released in order for that to happen, but the release of BDNF itself is activity-dependent, and it acts best on neurons that are already active. So if ever there was a mechanism that could explain why it is that people that exercise regularly seem to maintain healthier brains into later life, it's that one. It's that BDNF is activity dependent. And when I say activity dependent, I mean the electrical activity of neurons is what causes the release of BDNF. And then once BDNF is released, it has the best opportunity to stabilize and enhance the growth of existing neurons if those other neurons are already active. Now, if we were to list off all the different pathways and mechanisms by which exercise improves brain health and performance, it would be a list of probably, somewhere between 40 and 100 different molecular pathways, and probably, somewhere between 12 and 20 different anatomical pathways. And we certainly don't have time for all that. I don't think that's what you're interested in. I've tried to just highlight some of the key ones today.